Hello and welcome everybody to my talk Fun with Flags, where we bring back the fun into feature flagging with the help of OpenFeature. My name is Grazer Linuxtage and I'm a software engineer at Dynatrace and a prover and member at OpenFeature. Today we will talk about feature flags. So first, what are feature flags? Then about the OpenFeature community and project, about common problems with feature flagging, and if time permits, a short demonstration. So, what are feature flags? Feature flags enable, disable, or change the behavior of certain features or code path in our product or service without modifying the source code. This last part of the sentence is the important part. So you don't need to change your source code. You don't need to roll out a new version of your application. You can just remotely trigger or change a feature flag. And with that, you have a whole new feature enabled in your application. Why would we want to do that? With feature flags, we can coordinate our rollouts. We can reduce the risk, because if our rollout doesn't work out as expected, well, we can just revert the new feature. And we can use feature flags to experiment with our application. Because the best way to figure out if your application works better with a green or red button is to just try it out. And how do we do that? With feature flags, we can decouple the release from the deployment. So you deploy your new app version, but it doesn't mean that your users will get the new features if you hide them behind the feature flag. Instead, they will only see this new feature once you trigger or toggle your feature flag. This allows us to do risk-averse releases, but also allows us to do A/B testing if we divide our users into different categories and provide each category with a different version of the feature flag. This also allows us to do progressive rollouts if we base the decision of a feature flag, for example, on some time value. Now, from these different usages come different categories of feature flags. And those categories differ in the longevity and dynamism of the feature flag according to the different needs that we have for feature flags. So here I have a few different categories. At the bottom left, we see release toggles. This is what I mentioned before. So you have your new version that you want to deploy, but you want to gain a bit more confidence, so you don't deploy it to everyone at once. Instead, you do this rolling out. And that means that those feature flags will change only a few times in the lifetime when you switch them on. Maybe off again if it doesn't work as expected. And they are expected to live for a few days or weeks until your new feature is rolled out to everyone, and then you can delete them again. Next, we have operation toggles. Those can be used, for example, to hide the usage of a third-party library. If you're not satisfied with this third-party library anymore, just switch it off without needing to deploy a new version. Those can live for months or years, for as long as you want to use this library, which can be quite a long time. Then the more active ones, we have here experiment toggles, with which you do your experiments, as the name suggests. They live from a few weeks to a few months, just long enough until you have gathered enough data to make an educated decision and know which version of your application performs best. They can change with each request because you might want to give each user a different version of your application. And lastly, we have permission toggles. Those can also change with each request because every user might have different permissions, but the feature flag itself will live probably for a very long time. With that, we come to the OpenFeature project. So the aim of this project is to standardize feature flagging for everyone. And it is a cloud-native computing foundation incubation project. So OpenFeature is an open specification that provides a vendor-agnostic, community-driven API for feature flagging that works with your favorite feature flag management tool. And the important part here is that it's an open specification. That means that everyone here can read the specification, and you can also change the specification if you choose to do so. It is vendor-agnostic. That's one of our design goals, which means it's easy to switch from one feature flag vendor to another or to your own homegrown solution. For this, we have set up the following application flow. So at the very left, you will see your own application, which wants to request a feature flag. For that, it hits our evaluation API, which in turn, talks to the provider after it has collected all the necessary data that is needed to make the decision for your feature flag. And this provider is basically a wrapper around a flag management system, which might be a database or just a file that you deploy to your Kubernetes cluster where your feature flags are stored. You use this following Java example. So at first, we access the OpenFeature API singleton in this first line of code here. Then we set our provider, so the abstraction of your flag management system, and we wait for it to become ready. Here in this example, we use the in-memory provider, which is basically a hash map where you store the flag key and the associated feature flag values. Next, we get access to our client. And with this client, we can already do feature flag evaluations. It's as simple as that. For the flag evaluation, we have two important parts. The first one is the flag key. So this has to be unique within your flags, and of course identifies the feature flag. And secondly, we have the default value. This is very important, and I will come to that later. But you don't have to use Java. You can also use JavaScript, or if you prefer to write a backend service in Go, go ahead with our Go SDK. But of course, we also support other languages such as Python, C#, and many more. A few considerations for OpenFeature. So we promise that we will never break your code. I have shown you the architecture before. We have this evaluation API, we have the provider, we have the flag management system, and of course, things can go wrong. And if your flag management API is some distributed database and the network request hangs or gets somehow interrupted, of course, this wouldn't be good for you. But even if there is a network crash, or if the application throws an exception, or if we throw an exception because there's a bug somewhere, we will not break your code. Instead, we will catch the exceptions and we will default to the default value that you specified. And this is why it's important that you provide good default values, because your application has to work with them. Until now, I have shown you Boolean flag evaluations. But of course, we support many more types, for example, strings or numbers. Here in this Java example, we have integers and Boolean and doubles that we support. We also support more complex objects. So to recap on the evaluation API, it's the primary component that of OpenFeature that the application authors, and by that also the application interacts with. It allows developers to evaluate feature flags, to alter the control flow and application characteristics. It is designed to be easy to use and available in many languages, such as JavaScript, TypeScript, Java, C#, Go, Python, and many more, and some of them are currently under implementation. But of course, with feature flags, there also come some problems. When you think about feature flag, you might think about them as just a glorified if statement. And in a way they are. You just get your value and you use it. And this leads many teams to implement their own homegrown feature flagging solution. But many of them soon run into problems, because this glorified if statement is just the tip of the feature flagging iceberg. There are many other problems. How do you design your management interface? How do you do real-time flag updates or permission handling, controlled rollouts, audit trails, or flag evaluation metadata? With OpenFeature, we aim to alleviate at least some of those problems. Topics we will cover in this talk with problems of feature flagging are vendor lock-ins, dynamic evaluations, and obsolete feature flags. So at first, let's talk about vendor lock-ins. Why does this happen? So as I mentioned earlier, you might need feature flags in your application. So you can either choose a vendor-specific SDK, or you can make your own homegrown solution. In any case, you might run into those problems. So the first is migration pain. When you have chosen some commercial vendor for feature flags, and you want to choose another one instead, well, good luck changing every single line of code that uses feature flags in your code base. If you want to have additional features, if you implemented your feature flag solution yourself, maybe you can extend the feature set if you have the time for that. But if you've chosen a commercial vendor and some specific feature that you want isn't supported, it's not supported. So instead, we at OpenFeature have designed an architecture which allows you to easily swap out your feature flagging providers. To show this here, so this blue box would be your application, which hits our evaluation API with flag evaluations. This evaluation API is, of course, part of the OpenFeature SDK, and with that, part of the feature flagging client. And the SDK forwards your request to the provider that you have set. And it does that after collecting all the context evaluations and everything that it needs to do this. And this provider here in this example is just a simple accessor to some service, some database, whatever that might be. But there could also be multiple providers which are used after some strategy. So you choose which provider to use to make your actual flag decision. And as you can see from this picture here, it's very easy to just use a different provider. So providers encapsulate your feature flag management tool. And by doing that, they reduce migration pains that you will encounter sooner or later if you want to switch to a different provider. An example of how to switch to a different provider. So if we go back to our original code example, we have this line of code where we set the provider and wait for it to become ready. Here just a simple in-memory provider. And now we decide we want a more powerful one, the new provider. So we switch out this single line of code. And now all your feature flagging evaluation calls will hit this provider instead of the old one. And that's it. You don't need to do any more than that. Now, how do you handle dynamic evaluations? Dynamic evaluations mean that the evaluation of your feature flag changes based on some rule set that you specify. Now, why would you want to do that? As I've already explained further, you can use feature flags for rolling out releases. And if you discover at some point that your new version doesn't work on a specific version of a browser on some operating system, you can just revert back to the old version on this browser and operating system. So it's very easy to at least mitigate your problems when maybe even solve them. You can also use premium users when you assign user groups to your users, and then some feature flags might, so the evaluation might be based on if a user is part of this premium user group. You can use it to do A/B testing, where you assign different categories to users, and to one half of your users you roll out the green button, to the other half you roll out the red button. This is especially easy with OpenFeature because we support determinism for tests. And of course dog fooding, because you might want to try out your new features before you roll them out to your users. An example for how this targeting looks like from our FlagD reference implementation. So basically we just use JSON logic, but an extended version of it. So we have this, for example, the ends with function and a few others that we have added to it. And this is wrapped inside the if statement. So if the user email, which we access through this variable declaration, ends with the string here at engine.com, then the feature flag will evaluate to true, and otherwise it will evaluate to false. And of course you can nest ifs and other constructs, so you can make really powerful flag evaluation. And for this to work, you have to provide a context. The context stores, for example, the email address. And how this works is shown here. So you build your hash maps with key value pairs of the values that you want to use in your targeting rules. Then you wrap this hash map into the immutable context. And now you provide it as a third parameter to the getBoolean value evaluation method. So we have the flag key, the default value, and now also the context. There are also other rules, other use cases where you would want to change your flag evaluation based on some rule set. For example, you might use application information, the hyperscaler, are you an AWS or GCP, your operating system where your application runs on, and other environmental information. So all of this can be passed to the context, but since these values probably won't change during the runtime of your application, we have the static context. The static context you set once, and it will apply to every flag evaluation in its scope. So firstly, we have the API scope. This means that the context that you provide here will apply to every flag evaluation that you do in your application. The next one is on the client. So this context will be applied to every flag evaluation on this client. You can build quite powerful context structures with them that have to be merged somehow. And we have settled on this merge order. So the context that you set on the API level has the lowest priority. It gets overwritten by context on transaction, client invocation, and before hooks level. Now we come to the determinism problem, which is apparent when you do fractional evaluations and percentage-based evaluations. So if you do A/B testing, half of your users get into the A category and half of your users get into the B category. You want to, of course, make sure that every user will end up in the same category every time they visit your application, because otherwise this would lead to inconsistent behavior of your application. Nobody wants that. But how do we do that? We have this concept of the targeting key. This ensures the determinism by being a unique subject identifier. So you can tie that to the session ID if you want to have consistent behavior over the session, or to the user if you want to have consistent behavior for each user. And this is optional for the evaluation context, but of course if you want to use our deterministic features, you have to supply it. And you do it like that. So when you create a new context that you pass on, you can set as a first parameter the targeting key. Here in this case, it's the session ID, but it could also be user email or anything else. So the evaluation context is a container for arbitrary contextual data that can be used as a basis for dynamic evaluations. You can use it to experiment, to reduce the impact of rollouts, to increase your flexibility, and to provide determinism for the targeting rules. Now, the way feature flags are designed, they are in a way designed to become obsolete eventually. And that means that this feature flag will always evaluate to the same value anymore. And if you do that, of course, they become useless. So you want to remove them because otherwise they lead to dead code. So if you have rolled out your new feature, of course, the application will never revert back to the old feature. So you can just remove the feature flag and remove the old code. Otherwise, you will pile up technical debt and increase the complexity of your application uselessly. So you decommission them and remove the outdated feature, the obsolete behavior, and thereby also remove complexity from your application. But when can you be sure that you can remove the feature flag? Of course, this is not an easy question to answer, because you never know when your feature flag isn't used anymore. Except with OpenFeature, it's a lot easier, because you can use telemetry to monitor the flag usage. Before I dive further into this telemetry topic, let's take a look at the flag evaluation lifecycle. So if you call the get boolean value or whatever function on our provider, this whole chain will be triggered. So we start at the before stage. Here we merge together the context that you provided at a different level to us. We merge the hooks that you have set. And then we ask in the flag evaluation, the provider that you have set, so what is this value for this feature flag? And we get some response and end up in the after stage. If an error occurs during the before stage or flag evaluation, we instead go to the error stage. But as you can remember, we don't break your code, so we don't throw an exception to you. And eventually we will end up in the finally stage, and after that you get your result. And at each of these stages, before, error, after, and finally stage, you can now register a hook. This is arbitrary code that runs at well-defined stages during the flag evaluation. And you can set it in multiple ways, one of which is this way. So we have this already familiar get boolean value method, where we provide the key, default value, context, and now also flag evaluation options. And one of these options is this example invocation hook. And since we supplied to just this get boolean value method, it will only be used in exactly this method call. But we can also use hooks that are used on every call to a client or on every call in your application if you supply that on the API level. One example how you could implement a very easy logging hook is this. So we intercept the finally after stage and we just log that the feature flag has been evaluated. Now back to the OpenTelemetry, or to the telemetry with which you can monitor your flag usage. So OpenTelemetry supports OTel hooks out of the box. There are hooks that generate traces and metrics, which then you can monitor in your observability tools. So the traces are generated in the after and error stage, and they provide you with evaluation details such as the key, the provider name, and the variant of your flag that you use. Metrics, on the other hand, are the number of evaluation requests in total that you send off, how many of those requests were successful, and how many of them led to an error. And the error in this case would be, for example, a flag not found, or that you lost connection to your provider, or whatever. And we also have a counter how many flag evaluations have happened overall. Other use cases for hooks are, for example, if you want to log something when you evaluate a flag, or you can do further evaluation, and you can, in the before hooks, enhance the context that gets used in the targeting rules. So hooks are a mechanism that allow for the addition of arbitrary behavior at well-defined points of the flag evaluation lifecycle. With that, we are already at the takeaways of OpenFeature. So OpenFeature supports many concepts. Some of them I've already explained to you, like the easily exchangeable providers, dynamic evaluations, and hooks. But there are also others which I have not shown to you today, like tracking, remote evaluations, and many more. OpenFeature supports everyone within the software delivery lifecycle, not just developers, but also SRE and DevOps. And most importantly, it brings confidence to everyone. If you want to know more about OpenFeature, visit our website at openfeature.dev, or you can ask me. So if there are any questions, please feel free to ask them. Okay, if there are no questions, then we can proceed to the demonstration. Okay, for this, we have set up a very easy website called the Toggle Shop, where you can buy, well, toggles. And now I, as a user, would come to this web shop and I would think, oh, I really want this light switch. And so I add it to the cart and I proceed to the checkout. I enter my name, my email address, my shipping address, and my card number. So of course, everything is validated very good. Okay, and now I have made this purchase. And the important part about this website is that it's powered by OpenFeature. So we have this flags.json file. I hope you can read it. Which contains many feature flags that control certain parts of the behavior of the application. So there are quite a lot of them, but the one we are interested about is the offer free shipping feature flag. Because with that we can toggle the visibility of an offer free shipping banner on the website. So if we switch this default variant to on and save the file, now I go back to the browser and reload the page. Now we have here a banner free shipping on orders over $50. So changing a feature flag, as you can see, is really easy and it takes effect immediately. And now if I'm a user and I come to this page, then I see, oh, there's a light switch, which I want to have. But I know that I get free shipping over $50, so I will also buy the red switch. And I proceed to the cart. and enter my name again. And place the order. So, and how this works in the background, if you take a look at the source code, we have this layout. So this is a React app, so everything is in React syntax. And we set this OpenFeature provider here, where we supply the targeting key, which, as you all know, is the thing that makes our flag evaluations deterministic. And in the page itself, we have this React hook, where we query the value of the offer free shipping feature flag with the default value of false, which is the recommended way to do things. So if you introduce a new feature and you hide it behind a feature flag, the default value should be that you don't use this new feature. And then we can use this show banner variable to decide if you want to display the banner. In this case, we want to do that. So now let's take a look on the telemetry that we have generated. So if I use my favorite observability tool here, which is of course standard trace, I can run my query to see what telemetry has been generated by the website or by my use of the website. And then we get here all the information that we can have from a flag evaluation. We have a few which are flag evaluation specific. For example, which variant of the flag did we get on the website, or the key. So this is the SDK header feature flag. But if you search a bit, we will also find eventually, here this offer free shipping. That's the feature flag that we just toggled. We also get the reason, and so why we got this variant that we did get, and also a lot of other context that partially gets auto-enriched. We can narrow that down to the values that are actually interesting to us when we do feature flag evaluations. For example, what provider did we get? Here in this example, it's the offer provider, which is our OpenFeature protocol. The flag key, which variant did we receive? What is the reason why we got it? So here is static. That means that it's just the value from the flag file that we have set. But a more interesting one is the targeting match. So this means that a targeting rule has produced this result for us. And we also have the context ID, which is our targeting key. And we can use this targeting key to correlate feature flags with business events. So that's a feature that I've not shown you during the presentation, but the OpenFeature also supports tracking events, which use OpenTelemetry to track the usage of the app. And if we run this query, we will see a few tracking events. For example, here with the checkout or order received, which says that we have received an order over $60 and here over $20 with the context ID. And next we can use the context ID to correlate the feature flags with the events that we have received. And if we do some merging of those values and some statistics, we can see that on average, if we switch the feature flag to on, we receive orders of $60. If we switch it off, we get orders of $20. So in this case, it would be experiment which is immediately obvious that we should maybe show this banner to our users. Okay, so are there any questions concerning the demo or usage? Okay, in this case, I thank you for your attention and have a great time.